for topic 3, okay, about momentum and impulse, okay, and that topic we divide two subtopics, okay. 3.1 is about momentum impulse. 3.2 is conservation of linear momentum. For overview the whole topics, okay, we try discuss momentum and impulse, okay. The first one we try to understand what is actually is momentum, impulse, and conservation of momentum. For the conservation of momentum, we focus for the collision, okay, and that collision we have two type of collision is elastic and inelastic. 3.1 momentum and impulse. Students should be able, okay, first one is about define momentum P equal to mv and also impulse J equal to F delta T. The second one is solve the problem related to the impulse and impulse momentum theorem. Okay, for the equation is J, symbol for impulse, equal to delta P, or we can write mv final minus mv initial. Okay, the third one is determine impulse from FT graph. For subtopic 3.1, momentum and impulse. Okay, right now we focus linear momentum P. Okay, linear momentum, actually there is a vector quantity and same direction as velocity and object. The meaning of a momentum, actually there is a tendency an object to keep moving, or by definition linear momentum P is product object mass m and velocity v, or for other way in mathematical term we can write P equal to nv. So SI unit of momentum kgm as power of negative 1 or ns. Momentum vector we can resolve into two components. Okay, the first one is a vertical component y, and the second one is a horizontal component is x. Okay, let's say we use p as a symbol for the momentum. Okay, we resolve to py and also to px. Okay, px, okay, by using the angle, okay, angle theta, okay, px equal to p cos theta, or we substitute p with the nv cos theta, or the py equal to p sin theta, and we can write also mv sin theta. Okay, we continue with the example. Example 3.1. Okay, a 1.5 kg ball was kicked with initial velocity of 40 meter per second at angle 30 with the horizontal line. The question is, calculate the momentum P of the ball. Okay, and the question is also about resolving of P. That means they ask about horizontal component and vertical component of P. Okay. Okay. The first step for the solution. Okay. Calculate the P. P equal to mv. Okay. we substitute the value 1.5 kg and 40 meter per second. We got 60 p 60 kg meter per second. Okay, we done for p. Okay, we go for the resolve for the resolving how to find horizontal and vertical components. Okay, by within the diagram, okay, we resolve py and px. Okay, and we know px equal to p cos theta. Okay, we substitute the value, we got 51.96 kg meter per second, and also for py equal to 60 sine 30 equal to 30 kg meter per second. Okay, we continue for the subtopic 3.1 momentum impulse. Okay, because we already done is momentum, we continue with the impulse or J. Okay, the situation when two objects collides, okay, they exert large force on one another for a short period of time. Okay, during the collision, that force we call impulsive force. By definition, impulse is a product of a force F and the time t. Or we can write by equation J equal to Ft, where J is an impulse, T is a time, F, capital F, is impulsive force. Okay, impulse also like momentum, we consider as a vector quantity and has the same direction as the average force on the object. SI unit of impulse ns or kg meter per second. We go for theorem. Okay, impulse momentum theorem. Okay, consider a single constant force F capital letter act on an object in a short time interval that delta t. Okay, and through the collision. Okay, sum of F equal to dp over dt and equal to constant, and follow the principle of Newton's second law. Okay, we know the equation of impulse J equal to F dt. Okay, we relate with the question before. Okay, F dt also equal to dp. Okay, dp final momentum minus initial momentum. Okay, where F is an impulsive force, P2 is final momentum, P1 is an initial momentum. Okay, and the theorem states impulse of a body equal to the change of a body momentum. Generally, the impulse force is not constant. According to the graph given, okay, according to the graph given, okay, according to the graph given, generally the impulse force is not constant. Normally, how to use the value of impulse force, we take the average force. From the from the graph F versus time, okay, we can determine the impact through the area under the FT graph. follow the integration methods. Okay, momentum from the initial momentum to the final momentum, and for the F, from the initial time to the final time. Impulse we can divide two type of impulse. One, the first one is force is constant. Okay, means we can use the equation J equal to Ft. Okay, and the second type is force is not constant. Normally, we take impulsive force. We take the average force. Okay, through the equation, we use J equal to F average force time dt, or we can use by using the graph. The impulse equal to area under the graph force versus t. For the impulse, okay, we have two type of impulse. The first one is when the force is constant, we can directly use the equation J equal to F dt. Okay, the second one is force is not constant. Okay, and we need to determine first is about every force, average or every impulse force. Okay, we can use the equation J equal to average impulse force time dt, or if we use by using the graph force force versus t graph. Okay, we can determine the impulse through the area under the graph. Okay, the next is about chain of momentum or impulse momentum theorem. Okay, we know J equal to uh, J equal to changing in momentum. Okay, we know momentum is m we know mv. Okay, m is constant, but the changing is only in velocity. Okay, that means delta v equal delta v actually is a v2 minus v1.